Here is the strangest fact in the entire AI boom. The companies building it have effectively unlimited money, and the thing they cannot buy is electricity. The new AI campuses are measured in gigawatts, and 1 gigawatt is roughly the power draw of San Francisco. Money moves in seconds, a chip takes months, but a new power plant or transmission line takes most of a decade, and no amount of cash compresses that. So the race for artificial intelligence has quietly turned into something much older. A race for energy. In the 20th century, oil decided which companies dominated and which nations mattered. In this century, that role is passing to the electron. Today on the stack, we follow the wire: who is running out of power, who is locking it up, and who gets rich selling it. The comparison to oil is not a metaphor. It is a checklist. Oil mattered because it was the binding input. No oil, no tanks, no factories, no growth, whatever else you had. It reshaped geography, created choke points and cartels, and its price shocks toppled governments. Electricity is ticking every one of those boxes for AI. Compute has become the engine of economic power, and electricity is the fuel it burns. The binding constraint on building intelligence is no longer ideas or even chips. NVIDIA can ship you 100,000 GPUs long before your utility can power them, so the winners of the next decade will not just be whoever has the best models. They will be whoever secured the megawatts first, and that contest is further along than most people realize. Start with the size of the shock. A Department of Energy-backed study from Lawrence Berkeley National Laboratory found data centers consumed about 4.4% of all US electricity in 2023, and projected that share could reach as much as 12% by 2028. Globally, the International Energy Agency expects data center consumption to roughly double by 2030 to around 9 to 45 terawatt-hours, which is more electricity than Japan, the world's fourth largest economy, uses today. And the demand is arriving after 2 flat decades. US electricity use barely grew from 2005 to 2020, so utilities stopped planning for growth. Then AI showed up asking for city-sized loads on 18-month timelines. The grid is not failing. It is being asked to sprint after 20 years on the couch. Here is the bottleneck almost nobody outside the industry sees. Before a big new load or power plant can connect to the American grid, it waits in what is called an interconnection queue while engineers study what its connection will do to the network. Those queues now hold more than 2,000 gigawatts of proposed projects, roughly double the entire existing US power fleet, and the typical wait runs 4 to 7 years. So a data center that takes 18 months to build can sit dark, waiting for permission to plug in. The hardware is scarce too. Large transformers, the workhorse machines that step power up and down across the grid, now carry lead times of 3 to 4 years, and most are made overseas. In the machine economy, the humble wall socket has become the luxury good. If you cannot wait for the grid, you generate your own power, and that runs into the next shortage: the machines that make electricity. The world has 3 major manufacturers of heavy gas turbines: GE Vernova, Siemens Energy, and Mitsubishi Power. All 3 are now reportedly sold out into the end of the decade, with slot reservations and prices up sharply since the AI boom began. Think about what that means. A gas turbine order placed today may not spin until 2029 or 2030. Developers are trading delivery slots like commodities, paying premiums just to hold a place in line. It is the exact scramble we saw with NVIDIA GPUs in 2023, except the queue is measured in years, not quarters, and there is no startup that can 3D print a 100-megawatt turbine. Scarcity has moved down the stack, from silicon to steel. Now, watch what the richest companies on Earth do when they see this coming. Microsoft signed a 20-year agreement with Constellation Energy to restart a reactor at 3 Mile Island, the site of America's most famous nuclear accident, buying essentially all of its 835 megawatts. Amazon bought into a nuclear-powered campus next to Pennsylvania's Susquehanna plant. Meta signed a 20-year deal for the output of an Illinois reactor. Google ordered small modular reactors from a startup called Kairos Power. Understand what these deals really are. They are not electricity purchases. They are 20-year claims on guaranteed, around-the-clock power, locked up years before the plants deliver a single watt. It is the same move oil majors made a century ago. Do not buy the barrel, buy the field. For those who cannot wait even for nuclear restarts, there is a blunter option. Skip the grid entirely. When XAI built its Colossus supercomputer in Memphis, it did not wait in any queue. It rolled in dozens of mobile gas turbines and generated its own power on site, a move that outraged local regulators and worked anyway. The giant Stargate campus in Abilene, Texas, is being built with its own gas generation alongside grid power. Developers now market sites specifically on private power, your own turbines, your own substation, sometimes your own pipeline. The industry calls it behind the meter. It is the data center equivalent of drilling your own well because the water company is too slow, and it tells you exactly how binding the constraint has become. When the queue is 5 years, the powerful simply exit the queue. Every scarce resource eventually produces a political fight, and this one has reached your electricity bill. In PJM, the largest US power market, the auctions that pay generators for future capacity have hit record prices in back-to-back years, with data center demand cited as a primary driver. In corridors like Virginia and Ohio, household bills are up by double digits, and regulators are designing special data center tariffs to wall ordinary customers off from the cost. Notice the shape of this. Households and trillion-dollar companies are bidding against each other for the same electrons, and the households never agreed to play. In the oil age, that dynamic gave us price shocks and gas lines. The electron age is having its first one now, quietly, on utility bills. Zoom out to the map because this is where the oil parallel gets uncanny. In the oil age, geology made nations rich. In the electron age, cheap abundant energy is doing it again. Texas is booming as the place where power plants and data centers get built fast, with few permits and lots of gas. The Gulf states saw the shift early. The UAE is co-building a giant Stargate campus, and Saudi Arabia launched a state-backed AI company, both offering the same pitch, our energy for your compute. And looming over everything is China, which added more new power generation last year than the rest of the world combined and connects projects in months, not years. America leads in chips and models. On raw electrons, it is not close. The oil age had Petro-States. The machine economy is minting electro-states. So who actually gets rich? Follow the shortage. Nuclear operators won first. Constellation and Vistra were among the best-performing large stocks in America over the past 2 years, beating most of the tech companies driving the demand. Turbine makers won next. GE Vernova's stock multiplied on the strength of that sold-out order book. Behind them stretches a long, unglamorous supply chain that suddenly has pricing power. Transformer builders, high-voltage cable makers, the contractors who string transmission lines, uranium miners, and natural gas producers feeding the new plants. Notice the pattern from every gold rush in history. The prospectors, the AI labs, are still mostly burning cash. The people selling them electrons, turbines, and wire are printing it. Picks and shovels again. This time, the shovel is a substation. Now the uncomfortable question. What if AI revenue disappoints and the demand forecasts collapse? Utilities are planning tens of billions in new plants and wires based largely on hyperscaler promises, and if those loads never show up, ratepayers could be stuck paying for infrastructure nobody needs. Regulators know it, and some now demand deposits and guarantees from developers for exactly that reason. But remember the asymmetry from the dot-com bust. The fiber overbuilt in 1999 became the cheap backbone of the modern internet. A GPU depreciates in about 5 years. A power plant runs for 40. If the AI bet pays off, the grid build-out was necessary. If it fails, America still gets the modern grid it needed anyway. Of all the trillions in this boom, the electrons are the hardest ones to waste. Let's close the loop. A century ago, nations discovered that whoever controlled oil controlled the future, and everything followed. Alliances, wars, unlikely superpowers, the price at the pump deciding elections. Electricity is sliding into that same seat because intelligence has become an industrial product and electrons are what it is made of. That is why Microsoft is resurrecting 3 Mile Island, why turbines are sold out for years, why deserts are pitching themselves as compute empires, and why your power bill just joined the AI boom without asking you. You can print money, you can even print chips. You cannot print a gigawatt. That is the machine economy, and you are living in it. Next time on Mind Over Money, why smart people always buy at the top, from tulips to meme coins, and the wiring in your head that makes the top feel safe. Subscribe so you don't miss it.